Now that we've got the form down and we sort of have the reference to the exponential form, let's try just evaluating some logs without necessarily having to be given all the info. We were like kind of doing this a little bit already, but let's sort of officially do it. Let's see if we can do a few that are a little bit maybe less obvious as a part of it. How about log, let's do base 4 of 64. And how I'm going to write this, right, is so sort of log base 4 of 64 equals what really is the question. So we're going to say, right, that kind of equals question mark. And the idea here is that you're going to want to essentially either sort of mentally or just out on paper rewrite this into an exponential form and see if you can sort of figure out what's going to make this work. So the idea, right, is this sort of becomes 4 is the base, and then what we're looking for is really the exponent. 4 raised to the what is going to equal 64. So this really, the question here is like 4 to the question mark equals 64. How in the world do I get from 4 to 64 just using exponents? And the answer here is, well, okay, you can almost do sort of a guess and check. 4 to the 1 is 1. 4 2 is 16, right? 4 raised to the 2. 4 cubed would be 4 times 4 times 4 would be 64, right? So 4 cubed, 4 times 4 times 4, right? This would be for us, 16 times 4 would get us to our 64. So it must be that the power equals 3, and so then that's going to be our result. So this logarithm is 3. The logarithm, right, tells us what the exponent is that gets us from the base value to the interior number, right? So log base 4 of 16 is what's the exponent that gets us from 4 to 64. Let's do another one. How about log base 36 of 6, so equals question mark. So again, same kind of question, what's the relationship here? So this becomes, right, 36 raised to the what equals 6. How do I get from 36 to 6? And so the answer here is, well, I need to do root of 36, right? Root of 36 is 6. Well, what does the root look like as an exponent? And the answer is, well, that's 36 to the 1/2. So a square root is going to be a 1/2 power. So 36 to the 1/2 is 6, so that must mean that our logarithm is equal to that power. So the logarithm here is going to be 1/2. How do I get from 36 to 6? I got to take a root, square root, and so my result here, my power is 1/2. Let's run through a few more. Let's do log base 10 of, let's do 1 over 1,000. This would be, right, sort of as a decimal point, what are you going to have? 0, 0, 1, 1 1,000th, right? 1 over 1,000. So, okay, same deal. This equals question mark. What are we going to do? How do we get from 10 to 1 over 1,000? So 10 to the what is going to equal 1 over 10,000. So we have to kind of work through this little puzzle. 1,000, right? So 1,000 by itself is going to be 10 cubed, right? 1 over 10 to the 3. Now, that's 1 over 10 to the 3, not just 10 to the 3. How do I get 1 over? How do I get this reciprocal? Well, the only way to do that is it must have been 10 to the -3, right? That negative power flips us, and then we get the positive version of it. So the exponent here from the original 10 to 1 over 1,000, the exponent here is going to be -3. So a couple little patterns you can look for, right? Small fraction type values, right? Probably negative exponents to get there. Going from right? A bigger base to a smaller number, maybe some sort of root. Obviously going from a small base to a bigger number is going to be some sort of like positive exponent. You could imagine in theory we could do versions of this where we don't necessarily have a nice relationship between the two, in which case you don't necessarily get a great power. That's fine. Those are sort of calculator type problems. Your calculator can crunch it in a pinch. We're going to be focusing on the nice values because we're not really using calculators too much for our in-class work. Here, certainly on tests and quizzes, we'll be just looking at sort of standard, semi-decent numbers. If we had something that was maybe a little bit less obvious, but it was still sort of written out, right? Maybe something like the log base 7 of the 4th root of 7. So the idea here is like, okay, so 7 to the what equals the 4th root of 7. This is kind of purely just an exercise in trying to connect the 4th root of 7 to whatever the exponent is, right? The kind of base number here and the number underneath our root are the same. It's 7 and 7. So what the heck is the 4th root of 7? So as an exponent, that's going to be 1/4, right? 7 to the 1/4. 1/4 is going to be our 4th root. So the exponent here is 1/4. And that's going to be our log value. If we did a couple more shorter ones, zeros and ones kind of stuff, you could take something like log base 9 of 1. How do I get from 9 to 1? The only way to sort of get exponentially from 9 to 1, right, 9 to the sort of question mark equals 1. So the exponent here, right, would be 9 to the 0, right? 9 to the 0 equals 1. So the log, in some sense, regardless of the base of 1, the only way to get kind of 1 as a result is to have 0 as your exponent. So our log value here is going to be 0. You could do some trivial kind of stuff also, I guess, if we stick with log 9, maybe as one last example. You could do, for example, the log base 9 of 9, right? How do I get from 9 to 9? I'm not really changing at all. What the heck does that mean? What's the exponent that gets me from 9 to 9? Well, it's got to be our trivial exponent, so not 9 to the 0, which makes it 1. It's got to be just 9 raised to the positive 1. 9 to the 1 is 9. So if you have, right, the base value and sort of what you're doing the log of, if those guys are in sync, we're going to get 1. We could kind of generalize both of those a little bit. We'll do that as a last thing here. Right, the idea is if I've got the log base b and I'm trying to end up at 1, the only exponent that works, the exponent that's going to work here, is if your exponent is 0. So log base b of 1 is going to be 0. This, you'll notice, is kind of the opposite relationship in terms of the x's and the y's than our exponential relationship, right? This sort of goes with the idea that b raised to the 0 equals 1. That's the relationship we already kind of know and have. So that's true, and that checks out. Similarly, this kind of identity relationship, right? So if I have the log base b and I'm just trying to get to b, I'm not really trying to move at all, the exponent is 1, right? How do I get from b to b? And that checks out. It sort of goes with our exponential form, which would be b raised to the 1, gets us back to b. So we can get two sort of nice general rules out of this that are going to work. This is helpful. This is useful. They obviously don't show up all the time, but when they do, we can sort of take care of them really quick. So that's evaluating logarithms.